All right, region enclosed by the graph y equals x squared and x equals 2, so we can graph that pretty easily. X equals 2. So we're looking at this region right here, and this should go back to 0. And the x-axis revolves about the y-axis, so it's going around the y-axis. Volume of the solid generated is, so we can do this as a dx cut or a dy cut. Set up a little bit better for dx, so I'm going to do that. If we take that vertical rectangle and spin it around a vertical axis, what kind of a shape do we get? Shell. So we're going to have 2 pi times definite integral from 0 to 2 of average radius times the height times the thickness. So we know the thickness is going to be the cut, so dx. Average radius, in this case, it's just going to be x, right? If it just goes around an axis, it's just going to be x or just going to be y, depending on the cut. And then the height is going to be top minus bottom in this case, so it's just the parabola minus the x-axis, which is just the parabola. So we're going to have 2 pi times x squared, average rate times the height, that is going to be x cubed times dx. So if we do the antiderivative, we get 1/4 x to the 4th. Oops. And we're evaluating that from 0 to 2. So I'm going to bring that 1/4 out in front, so we get pi over 2 out in front. And then it's 2 to the 4th minus 0 to the 4th. So 16 times pi over 2, we get 8 pi.